Today in Capechi's Corner, we're going to talk about similar polygons. Two figures that have the same shape are called similar. Now notice I didn't say the same size. Congruent figures have the same shape and the same size, but similar figures just have the same shape. Two polygons are considered similar if their vertices can be paired so that two things are happening. Their corresponding angles are congruent, and their corresponding sides are in proportion, meaning that their lengths have the same ratio. So again, if you look at our example here, if I say that ABCD is similar to EFGH, all the sides have the same ratio. However, their corresponding angles are still going to be congruent because remember, for example, in this quadrilateral, the sum of the interior angles have to be 360, and that's going to stay the same regardless of the size of the figure. Now let's look at our sides. I have AB is listed first, and so is EF. So I'm going to say that AB and EF, let's see what that ratio is. AB has a length of 6, and EF has a length of 12. So when I simplify that, I'm going to get 1 over 2. If I do the same with BC over FG, BC has a measurement of 5.4, and FG has a measurement of 10.8. Again, if I simplify that, I'm going to get 1/2. And this ratio will be the same for all pairs of sides that are considered similar, and therefore their corresponding sides are in proportion. Now, when I'm looking at the scale factor of a polygon, remember we're looking at the ratio of the lengths of two corresponding parts, not the angles. So I need to identify which pairs of sides from each of the polygons are similar. So I'm going to start just by listing the first one. I have JKLM is similar. So now J, I notice, has a 90 degrees. I also notice the M has a 90 degrees. JK looks like it's the shorter side there from the 90 degrees to the angle that has just the one hump. So that's going to match up with ST, and then L is my angle that has the 2 humps, and so is U there, so I'm going to put that there. And then I'm going to match up also STU goes with V. So now I can look at the scale factor. So JK has a measurement of 20. TS has a measurement of 24. So when I simplify that, they're both divisible by 4. I get 5 over 6. I'm going to do the same thing with JM. JM has a measurement of 10. SV has a measurement of 12, which also simplifies to 5 over 6. When I look at segment ML, it has a measurement of 30. Segment VU has a measurement of 36, and again, that simplifies to 5 over 6. And in KL, that has a measurement of 14. TU has a measurement of 16.8, and that also simplifies to 5 over 6. Now number 2 says what's the ratio of the perimeter? So I'm going to add up the sides of each of the polygons. If I first do the one on the left, JKLM, I get 20 plus 10 plus 30 plus 14, which gives me 74. And the polygon on the right, STUV, if I add 24 and 12 and 36 and 16.8, I get 88.8. Now that will simplify also to 5 over 6, which, think about it, that makes sense. If each of my side lengths have a ratio of 5 over 6, and then when I add those sides together, I should still have the same ratio, 5 over 6. Now question number 3 says, what is the measure of angle T? Well, the angle measurements I have so far, I have some 9-degree markings, and measure of angle T, if I'm looking at my similarity statement, I know T and K match up. I have a measurement right here, that measurement of angle K is equal to 100. So now remember, angles are not in proportion. They actually are congruent. So the measurement of angle T is 100 degrees. Let's look at one more problem for today. It says quadrilateral ABCD is similar to quadrilateral HJKL. So we're given a statement. We know which sides will match up together and which angles. And question number 1 asks what the scale factor is. So I am not given a lot of sides here. I have 8 and I have 4, and then I have X and I have 6. So on my polygon on the right, I only have KL. So I'm going to have to match that up with CD. So the measurement of CD is 4 and the measurement of KL is 6. So that simplifies to 2/3, so that is my scale factor. In number 2, I'm asking to find the value of x. So I'm going to take my scale factor, 2/3, and I'm going to try to figure out what the value of x is. Now, my 2 goes to my polygon on the left, so that has to stay as my numerator. So I'm looking for HL, and that matches up with the segment AD in similarity. So AD has a measurement of 8 over, I'm going to make over x, and now I can cross multiply. So I can say 2x is equal to 24, so x has a measurement of 12.